Hi guys, this is Meghana Bia studying in Sri Venkateshwara College of Engineering, currently in 6th sem. So today's my topic is about solar cells. So we'll see the agenda of today's topic. So we'll see what is solar cell, construction of solar cell, working of solar cell, advantages and disadvantages, and then applications. So what is solar cells? Solar cell is also known as photovoltaic cell. So it is nothing but electrical device that converts the light into electricity by the photovoltaic effect. So it is 5 to 11 times more expensive to produce the electricity from the sun than it is from fossil fuels and the nuclear fuels. And also they are made up of special material that are semiconductors. So these semiconductors produce electricity when sunlight falls on its surface. So beyond sunlight, lamplight and also artificial light also can be used. So silicon is widely used solar cell material, which is crystalline silicon is used 80% and amorphous silicon is used 20%. So next is construction. So here you can see the construction of the solar cell. So the upper portion of the solar cell is covered with the glass roof, and the n-type material is placed between the glass roof. That is it is a type of semiconductor material, and also p-type material is also made up of semiconductor material that is placed below the n-type material. And the lower portion of this device is covered with metallic sheets, which is also called a base substance. And also you can see that the upper portion of the glass sheet, the metallic strips are placed that behave like a electrode. So here the p-type is large layered and it is doped with trivalent impurity. And also the n-type is thin layered and it is doped with pentavalent impurity. That is, n-type region is of 0.3 micrometer and it is a highly doped one, and the p-type region is of 300 micrometer and it is lightly doped. So here you can see in the diagram. Next we'll move on to the working of the solar cell. So here is a picture of working. So you can see that p-type semiconductor, n-type semiconductor, and in between the depletion region, and also the bandwidth structures. Now we'll see the working. Solar cell, it works based on the principle of photovoltaic conversion. So photovoltaic conversion is a process of direct conversion of light into electricity at the atomic level. So some material will exhibit a property known as photovoltaic effect that causes them to absorb the photon of light and release the electrons. When free electrons are captured, electricity is generated. So we'll see in detail how this is done. As we all know that majority charge carriers are the free electrons that are present in n-type material, and also the majority charge carriers, the holes, are present in p-type material. So when the n-type and p-type material are arranged like this, some electrons will cross the boundary and fill the holes that are present in p-type, and the holes are created in n-type. So the holes which is positively charged and the electrons which is negatively charged, the region developed by electrons and the holes is called depletion region. When the sun rays incident on the n-type materials in the form of photons, it reaches on the depletion region after crossing the n-type layer. Since n-type layer is thin, it crosses this layer and falls on the depletion region. We'll see the bandwidth structure of the semiconductor, that is the band structure of the depletion region, to understand this. So you can see in the right side of the slide, the bandwidth of a semiconductor is displayed. So let us consider a valence band is completely full, that is no holes, and the conduction band is completely empty. Therefore, there are no charge carriers in the depletion region. When sunlight photons falls on the valence band and it has a sufficient energy, that is more than a band gap, and then some of the electrons are observed, that energy and used to jump it uses that energy to jump into the conduction band. So when this happens inside the depletion region, electron hole pair is generated due to the sunlight. So the electrons is pulled by the positively charged holes and is attracted by the negatively charged. As a result, there is a positive charge generated at the p-type and a negative charge generated at the n-type. And we can see that metallic contacts are connected to p-type and n-type for for the device, so which is connected to a bulb across it, and then the free electrons will start to flow, means that current flows between the positive and negative electrodes. So therefore, the output of the electrical energy of a solar cell depends upon the intensity of the light. So if the intensity of the light has more photons, more electricity is generated. We'll see the applications of no, sorry, we'll see the advantages and disadvantages of the solar cell. So advantages is it does not require any battery. The PN junction itself acts as a battery and there is a continuous flow of electricity. And also it is a renewable and pollution free energy. So it reduces the current bill, so that is electricity bills. And disadvantages is that it requires a lot of space area for installation or anything might be, and the initial installation cost is high. So then the solar energy during the winter is less, because we need sunlight and the electricity which depends on the intensity of light. So if in during winters there the intensity of the sunlight is less, and no solar power at night and cloudy days. So next we see the applications of solar cell. So it is used in toys and watches, it is used in electric fans, and mostly it is used in the field of satellites, and also it is used in remote lighting systems. So this is the end of the video, guys. I hope you guys liked it. Thank you for watching it. Please like, share and subscribe. Thank you.